Find the derivative of an exponential function with base e. So in this video, we're going to look at the derivative of the exponential function. And yes, I am putting emphasis on the word the because the exponential function talks about a very specific function, and that function is y equals e to the x power. So this is our exponential function with base e. So now how do we take the derivative of this special function? Well, as it turns out, the derivative of e to the x might be one of the best derivatives ever, because the derivative of e to the x is just e to the x. Now, stop, think about that for a second. The derivative of a function is the original function, meaning the output is the same as the rate of change. Crazy. But anyways, more on that later. The other derivative we need to take is if we have a composite function of the exponential function, such as e to the u power. So if we have a function inside of the exponential function, that means that we're going to have to use the chain rule to evaluate it. Well, the chain rule says we take the derivative of the outer function, which is e, and the derivative of e, as we just determined, is e. And then we have to multiply this by the derivative of the inside, so we're going to multiply it by u prime. And there we go. The derivative of e to the u is e to the u times u prime. So let's take a look at our first example. So here we want to find the derivative of 3 e to the x. And this is going to be pretty simple. So let's see. We're going to have f prime of x is equal to. We know that when we take the derivative of a function, we can just ignore the coefficient because we talked about that being a property early on in calculus. So we'll leave the 3 alone. And then the derivative of e to the x is just e to the x. And there you go. We have our derivative. F prime of x is equal to 3 e to the x. Alright, so now let's take a look at our next example. So here we want to take the derivative of e to the 4x. And as we can see here, we do have a composite function, with 4x being the inside function and e being the outside function. So let's just remember that d dx of e to the u is going to be e to the u times u prime. And in this particular example, u is going to be 4x, and u prime will just be 4. So now that we have all the pieces, we can actually take the derivative. So f prime of x, let's see, we're going to have the derivative of e, which is just e. We're going to put the inside back in, which is 4x. And then we're going to multiply by the derivative of the inside, which we already found to be 4. And then we can just simplify this. So we're going to end up with a final derivative of 4e to the 4x. Boom. Done. Next problem. Alright, next up we want to find the derivative of e to the x squared minus 1 power. So here we have another composite function, except now our inside function is a little bit more complicated than just 4x, but not a whole lot. So just like before, we can identify our u, which is x squared minus 1, and the derivative of our u, being u prime, will be 2x. Then we can come and we can take the derivative. So let's see. We want to take the derivative of the outside function first, so that is e, because the derivative of e is just e. Then we're going to put the inside function back on the inside, and then we're going to multiply by the derivative of the inside function, which we've already found to be 2x. And then we can simplify this to be 2x times e raised to the x squared minus 1 power. There we go. The derivative. Now our final example gets a little bit more fun, because our final example has a function 9 times e raised to the x raised to the negative 9 power. So it's like the inception of functions. We have a power inside a power. No way! Fortunately, it doesn't change anything we do, because we still have an inside function. So we can see here that our u is going to be x to the negative 9th. And then we can use the power rule to take the derivative. U prime is going to be negative 9x to the negative 10th, because remember, we want to subtract 1 from the exponent. All right, so now we have all of our pieces, so we can take the derivative. So f prime of x, let's see, remember we said we don't have to take the derivative of coefficients because we can factor them out of the derivative, so the 9 will stay alone. Then we can take the derivative of the composite function, which says take the derivative of the outside first. The derivative of e is just e. Then we're going to put the inside back in, and then we're going to multiply by the derivative of the inside, which is negative 9, x to the negative 10th power. And then from here we can simplify. And we're going to have 9 times negative 9, which would be negative 81, and then times x to the negative 10th, times e raised to the x raised to the negative 9th power. And there we go. We have our derivative. Now, if you wanted to show off, which again you don't have to, but if you wanted to show off, which, well, I do, we could even rewrite this as negative 81 e to the x minus 9th power all over x to the 10th. So we can get rid of that negative 10 exponent. But wait, there's more. We can even be fancier and rewrite this as negative 81 e to the 1 over x to the 9th all over x to the 10th, and get rid of all the negative exponents. But again, Nash is being fancy. Our original answer is 100% acceptable. And alright folks, that is it. That is finding the derivative of an exponential function with base e.